Brings me to another point, and I've asked this question several times during these podcasts. Who cares? Where's the scientific interest? Where's the driver? Apart from the 350 odd people in our collaboration, who really cares about what we're doing?
So, I actually I think that the black hole stuff that we do is one of those things that, almost everything else, you're like, how does, your average Joe get affected? It doesn't change the price of bread, price of eggs is still $40 a carton. So, but I think the black hole image stuff is one of those things that, like, for some reason, everybody loves this stuff because I think it represents like the boundary of human knowledge. Everybody kind of knows that black holes are like these weird exotic things, even if you know nothing about them. And if you ask like 100,000 people what they knew about black holes, the most common sort of fact that everybody knows, even if you just like kind of intuit it, is that light can't escape, so you can't see them. And so taking an image of this thing that nature is like, you're not supposed to look at that, it's a very human thing to do. And I think
Mm-hmm.
from a purely like public interest perspective, that's a big driver. But it's also really interesting from like a humanities body of knowledge perspective, right?
Yeah.
The black holes are kind of governed by general relativity as far as we know. But once you get down to that singularity in the center, the laws there start to conflict. The explanations, the models we use to explain it start to conflict with the other very successful theory, quantum mechanics. And quantum mechanics and general relativity are the two most successful theories in human history. Like they've hundreds of over 100 years of experimentation to crazier and crazier precision for both, and we haven't found a single instance where they're wrong. And every time we thought they were wrong, it turned out we were just wrong about how we were interpreting something or how we were designing some experiment.
Yeah.
And so there are these two very, very successful theories, and we've been able to sort of keep them separate because they disagree in a fundamental spot, the center of a black hole. But we were able to keep them separate because we were like, well, black holes probably aren't real. And actually, maybe you can look at this disagreement and say, here's an object that makes these theories conflict. It's probably not even real because nature seems to like these two theories. But now we know they are real. And every time I look at that image of the black hole, it's like inside of that thing, one of the two theories that we know should be correct breaks down. And if it's quantum mechanics, that's really, really bad. And if it's GR, that is even worse. So it's like a preemptive, uh-oh, we have work to do as a physicist. Um, and it's a reminder, honestly, maybe a like a reminder of humility. Like we don't know everything, and that's an image of a lot of stuff that we have no idea what's going on. So
Yeah, no, absolutely. Absolutely. Couldn't agree more. I think for me, one of the fundamentals I think about, and I'm going to ask you a very easy question in a second, but I think it's an awful lot of people will ask this question as well, is we hadn't, and we're spoiled with the technology we have access to, the computing power, the very sort of intelligent people in our collaboration. We're completely spoiled. But don't forget, we've only been imaging black holes for 5 years, and their existence has been theorized for, let's be generous, 80 to 100 years, depending on when exactly the person came up with it. But the thing I always think about is how the image proves that black holes definitively exist. Well, they were previously theorized, and we see we see intense X-rays coming from them. We see stars orbiting them with these very extreme velocities. That has to imply there's a very massive object there that you can't see. But
probably it's a
this,
gravistar, David.
yeah, well, that could be that. But essentially, we've sort of got to the point where we have proof of this very complex system that was for a long time just theorized. And so the second part of that, and you said something very interesting to me, is that black holes, we haven't been able to see them. For the average Joe and Joanna on the street, the answer, the question I would have if I was one of those people without our scientific education that we've been so privileged to have received, why can we see this black hole? Because I thought inside black holes you don't see any light at all. So I don't really understand that part
It's
as
true,
well
and
as perhaps.
it's a really important nuance. You're right. Once a light gets inside of a black hole, it can't escape. But because the gravity of a black hole is so strong, there's a region outside of which that photons can orbit either multiple times or just once before they escape eventually. So basically, like inside the event horizon of a black hole, you're right. No matter how fast you're moving, no matter which direction, no matter which god you pray to, you're not going to escape the black hole. But just outside of it, if you're moving at the speed of light, like, light. If you're moving at the speed of light, like the light that enters our telescopes, and you have just the right trajectory, just the right angle, you can get out of the black hole. And it turns out the right trajectories and the right angles required correspond to photons making certain loops around the black hole. And that's what produces these rings in our imaging, this lensing of photons that almost get sucked in but don't. And so we call it the black hole because that's the best we can do. What we're really seeing is the shadow of the black hole on the glowing accretion matter around it. And some people might say, well, it's not really the black hole itself. And that's kind of true in the same way that, look, you're not taking a picture of the Earth, you're taking a picture of the crust of the Earth. But for all intensive purposes, this is sorry, I'm so sorry. But this is basically an image of the black hole, and I think it's like in terms of what we're imaging. Although our images will get better, higher resolution, and we'll be able to see more and more extraordinary things. For us, this is the best we'll ever be able to do without going inside of a black hole. Is imaging the photons that are just about to fall in.
Yeah, that's right. And I think, we played good cop, bad cop there in the science part of it. But I think that's fundamental for our audience to understand, is that we're observing emission of material or photons from outside the event horizon. As you rightly said, they're being orbiting the black hole and being lensed and so on.